Here we are given some questions from group theory. The first question is, what is an abelian group? If the elements of a group are commuting, then the group is said to be abelian. Consider a group with elements E, A and B. If AB equal to BA, then G is abelian. Second question is, what is the cyclic group? A group constructed by a single element is called a cyclic group. If G is equal to A square, A cube, then A power n is equal to E, then G is cyclic. For example, consider a group with 4 elements, I, minus 1, minus I and 1. It is cyclic because here the value of A equal to I. With the help of the single element I, we can construct the entire group, because if A equal to I, A square is minus 1, A cube is minus I, then A power n. Here 4 elements are present, so A power 4 is equal to identity element 1. Here the identity element is 1. If you multiply any element with the identity element, you can get the same element. Therefore, the given group is cyclic. You know that all the cyclic groups are abelian in nature. Here there is a cyclic group of order 4. And what is meant by order of a group? The number of elements present in a group is called the order. See, this is a group of order 4. What is meant by symmetry operation? The symmetry operation is the movement of a body such that the body appears the same as before even after the move. For example, seat operation of water. If you provide rotation through the axis passing through oxygen in the clockwise direction, then 2 hydrogen atoms are interchanging their positions. The oxygen also changes its phase. However, there is no change in the structure of water molecule. We are getting equivalent structure of water molecule. This is called symmetry operation. What are the basic symmetry operations? Identity operation, inversion, reflection, proper rotation and improper rotation are the basic symmetry operations. What do you mean by improper rotation? A rotation followed by reflection through a plane perpendicular to the axis of rotation is called the improper rotation. What is a symmetry element? The symmetry element is a geometrical entity about which a symmetry operation is performed. The symmetry element may be a point, plane or axis. What are subgroups? Subgroups are smaller groups that are constructed from larger ones. For that, construct a subset using a group. The constructed subset itself is called a subgroup if it satisfies the conditions of a group and is subjected to the same binary operation that is obeyed by the actual group. What is a point group? A point group describes all the possible symmetry operations of an object. For example, in the case of water molecule, these are all the possible symmetry operations. Identity element, 180 rotation, reflection through the horizontal plane, reflection through the vertical plane are the symmetrical operations. If you construct a group using all these symmetrical operations, that is called as a point group. What is meant by matrix representation of a group? The process of expressing the symmetrical operations of a geometrical structure in terms of respective matrices is called matrix representation. So this is for E, this is for C2, this is for sigma B, that is reflection through the horizontal plane. This is for the reflection through the vertical plane. These are all the matrix representations. What is meant by a reducible representation? A representation of a higher dimension that can be reduced into a representation of a lower dimension by the process of similarity transformation is called reducible representation. Reducible representations are called block diagonal matrices. Say this is an identity matrix. If you make the square bracket for the elements non-zero elements, that is called reducible representation, which means that we are reducing the dimension of the matrix to a smaller one. Those representations which cannot be further reduced to a representation of lower dimension are called irreducible representations. This is a definition for a group. What is a group? A group is a set of elements that are finite or infinite in number. If it is finite, it is a finite group. If it is infinity, that is called infinity group. And the group should satisfy the following conditions: composition rule, then presentation of identity element, the presentation of inverse element, then the associative law. These four laws are satisfied, then only you can call that one as a group. What is meant by isomorphism? Two groups G and G dash with the same order are said to be isomorphic if a unique one-to-one correspondence exists between their elements in such a way that product corresponds to product. See, G is a group. These are all the elements E, A, B, C and so on. G dash is another one group. E dash, A dash, B dash and C dash and so on are the elements of G dash. Both the groups are having the same order. Suppose the element A is in contact with the A dash, B in B dash, C in C dash. At the same time, the product of A and B will provide C. Then A dash, B dash is also having the value C dash. Then these two groups are said to be isomorphic to each other. What is meant by homomorphism? Homomorphism between two groups resembles isomorphism, except that the correspondence is not necessary to be one-to-one but many-to-one. See, here we have given the explanation. Let H contains few elements, order is G. Another one group G contains more elements, the order is N into G. Suppose it is possible to split the elements of G into G sets. These are all the sets of G. Each contains N elements. One element of H corresponds to every element of G, and if at least one element of G corresponds to every element of H, and if the correspondence is such that AB equal to C in the group H, then the product AI and BI of G belongs to the set CI of G. Here is a relation we have given to correlate homomorphism. Give the statement of orthogonality theorem. Orthogonality theorem concerns elements of matrices constituting an irreducible representation of a point group. This is the mathematical form of orthogonality theorem. Here the first term, that is I of R, so Mn denotes the element in the mth row and nth column of the matrix corresponding to an operation R in the ith irreducible representation. Gamma of I of R Mn is nothing but element in the mth row and the nth column of the matrix corresponding to an operation R. This is a symmetrical operation in the ith irreducible representation. This star represents the complex conjugate. Here Li and Lj are the dimensions of ith and jth irreducible, H the order of the group. Here order stands for the total number of symmetrical operations involved. Then what do you mean by similarity transformation? Consider A, B and X are the elements of a group G. If there exists a relation such that X inverse A X equal to B, B is said to be the transformation of A by X, and the two elements A and B are said to be conjugate to each other, and the transformation of this type is called similarity transformation. Show that the four matrices E, A, B and C form a group under multiplication. The given matrices form a group under multiplication if the product of any two matrices should provide a matrix equivalent to any above 4. A into C is equal to E. C into A is also E. Then find out the value of B square, that is B into B, that is E. These relations show that the given matrices form a group under multiplication.